All right, so what I want to do today is I want to show how we can check the solutions to an equation. This is something that's going to be on your homework for sections 1.5 and moving forward, because we know how to graph lines, we know how to work equations, but then we have to check to see if things are solutions. So when you're given something that says something like y equals 5x minus 2, all right, what I might do is then ask you, is the point, I'll do it in a different color to make it clear, is the point 1, 3 a solution to this line? And when I ask, like, is it a solution, what I'm asking is, another way of saying it is this point on the line? I might say something like that. Is this point on the line? That's what I'm asking. These are pretty much asking the same thing. So there's two ways to solve this. You know, much like anything in math, there's multiple ways to do this. One way to do it is to graph it. So you do your xy plane. I look at my equation here. I see that my b is negative 2. I see that my m is 5. So I go down 1, 2. And then I go up 1, 2, 3, 4, 5, and then over 1, like this, like this, like this, like this. And then I graph it. I make my arrowheads. And then I check to see, is the point 1, 3 on the line? And so I go over 1 on my x, I go up 3, and it's right there. And I can see, as long as my lines are neat and clear, that yes, it is on the line there. I can see for sure that it's on the line. So that means it is a solution. 1, 3 is a point on that line. Now maybe I'll give you the same question, but I won't give you a place to graph it. I'm going to ask you to do it algebraically. So this is the first way. Here's the second way to solve it. Second way. In this case, we're just going to substitute 1 and 3 into our original equation. So if our original equation is 5x minus 2, what I'm going to do here is I'm going to plug in these values into this equation so that my y is 3, and that's going to equal 5 times my x, which is 1, and then I'm going to subtract 2. And if I get this equation to equal itself, then I know it works. So I'll have 3 equals 5 times 1 is 5, which is minus 2, and 5 minus 2 is 3. Does 3 equal 3? Absolutely it does. And so that means the point 3, 1, yes, or 1, 3, my apologies. So that means yes, it is a point on the line. All right. Okay, and so that's how we do it. You can either draw the line out and plug it in, or you look at what our variables are, our x and our y, and plug it into our x and our y on this equation here. Does anybody want to see one more the second way? Because it seems like a little confusing. Yeah, absolutely. I'm going to do one more for you guys. I totally get it. So it's going to look something like this. Here's another equation. So it'll say something like y equals negative 1/2 x plus 8. And this time the point that it's asking for is 0, 4. And we're going to try to figure it out. And this time I'm only going to do that second way. I'm not going to graph it. I'm just going to do it with algebra. Okay? So keep in mind right here, this is x comma y. And I see that my y here is 4. So where my y is here, I'm going to plug in 4. All I did was I took my y of my point and plugged it in for my y in the equation. I'm going to copy down everything else until I get to my x. And here, for my x, I'm going to plug in 0. So this is going to be times 0. And then I'm going to add 8. And again, all I did was I took my 0, plugged it in. Just substituting in. Instead of the y, I have the 4. Instead of the x, I have the 0. And I'm going to see if this equals each other. So I have 4 is just 4. Negative 1/2 times 0, well, that's going to be 0, because 0 times anything is 0. If I have nothing, I have nothing. It doesn't matter how many nothings I have. 0 times negative 1/2 is 0, plus 8. 4 equals 8. In this case, 4 does not equal 8. So I would say, no, the point is not on the line. It's not on the line. And I know this algebraically because by plugging it in, I see that it's not a usable solution. But if I really wanted, I could check my work by graphing it. So I have the point 0, 4. 1, 2, 3, 4. 0, 4 lives right here. And what I'm going to do is I'm just going to graph my line here. I'm going to graph my line. So I have my B is 8. 5, 6, 7, 8. It's all the way up here. And then my slope is negative 1/2. So I go down 1 over 2. Something like this. When I graph my line, it goes like that. Put my arrowheads on it. And I see that, yeah, that point, nowhere close to being on that line. There's no way that this point is on that line. So yeah, nope, the point is not on the line. Any questions that I can clarify on this? Awesome. So that's what we're going to be doing today.